Okay, so welcome to section 2.1, which is linear functions. And this, once again, should be a review section. So linear functions. So let's consider what we should already know. So I'm going to plot a line, x and y coordinate axes. X and y. And if I plot a line, f of x, like so, f of x being a linear function, then we have a few things going on. Namely, if I rise, oh boy, okay, I guess I'm going to have to just draw this over the run from one point to the next. So say I have 1 point here and 1 point here. So the slope, so I'll do slope m is going to be the rise, which is the change in y. Change in y, which is the rise. Divided by, oh, that was pink, the change in x, which we call the run. Okay, what's more, we also have this point, what color should I use? Here. Oh no, I shouldn't have used that color. Let's use purple. So this point here, which is the y-intercept. So the y-intercept will be at 0, comma b. But what about the x-intercept? The x-intercept well, from b, I want the negative slope. So it's negative b over m, comma 0. And I'll show you that in a moment, and we'll prove that that's true. Okay, so definition. So a linear function, that's what we're defining. So a linear function is a function whose graph is, of course, a line, is a function whose graph is a line. With well-defined slope. So this is going to be important, with well-defined slope. So we'll come back to what that means in a moment. With well-defined slope and expressed in either. Number one will be slope-intercept form of a line. Slope-intercept form. Slope-intercept form, which is f of x is equal to mx plus b, where m is equal to the slope and 0, comma b is equal to the y-intercept. Hence slope and intercept, slope-intercept form. Then the next definition, let's use this color. There's another form called the point slope form. Point slope form, pardon me. Point slope. So point slope form of a line. Oops, why is that not working? Okay, it's point slope form. And that's given as y minus y1 is equal to m times the quantity x minus x1, where p equals to x1 comma y1 is on the graph, and m is the slope. So hence we've got a point on the graph and the slope. So that's a point slope form of a line. Okay, so let's consider a few cases, 4 cases. So what I'd like to do is I would like to draw 4 different x and y coordinate axes. So let's consider. So actually maybe I'll just work on, I'll make them small. Probably that's small enough, x and y. Maybe I'll make this a bit larger down here. Okay, I'll copy and paste because I want 4 of these. Okay, so I might have enough room to move this over just a bit so it's more. There we go. Okay, so first let's consider a line that looks like so. So this is my linear function f of x. Do you agree that the rise from one point over the run is going to be, so the slope, which is going to be plus over plus, because the rise is positive, and the run is also positive, and I'll show that with arrows. So from this point here, number 1, to this point here, number 2, my rise was going upwards, and my run was going to the right. So if I have the ratio of both positive, that's going to be greater than 0. So note it's going uphill. So let's note that. What color shall I note that in? Green. How about green? So uphill in reading direction, right? To the right. Okay, similarly, let's say we've got a function that looks like so. So now this is my f of x. Once again, let's look at maybe a point here and a point here. So if I look at my rise from point 1 to point 2, my rise is now negative, right? So my slope is going to be rise and negative. But now my run is still going to the right. So going to the right is still positive. So, pardon me, I have a negative slope. So I notice that this function is going downhill in reading direction, so it's negative. Of course, the next one is going to be a horizontal line. So if this is my f of x between any 2 points, I rise 0, right? I can't rise. So the slope is going to be rise 0, but I can run anything I like. And it's a positive run, not that it matters. Because 0 divided by any number is 0. So this would be static, or, static. No, instead of, I'll just write horizontal, make your life easier. Horizontal slope. So a horizontal slope is 0. And of course the last one, I'm actually going to draw this in a different color. This, I cannot put f of x. So the slope here does not exist, right? Because if I look at any 2 points, I can rise whatever I want. Oh, I forgot to name these 1 and 2 over here. And I will name these 1 and 2 over here. So my slope, I can rise whatever I want. Positive. The problem is going to be that I'm going to be dividing by 0. So in this case, the slope does not exist. And note that this does not pass the vertical line test because it is a vertical line. So this is not even a function. So not a function. Maybe I should put that beneath instead of on top here. So not a function, right? So a vertical line might be a relation, but it's not a function. So this is what we mean when we say well-defined slope up here. It cannot be a vertical line. Okay, so let's recall that the slope we know is going to be the change in y over the change in x. And we call that, actually let me color code it. So in English we would say change in y let me put that y a bit farther away from the n over change in x. Or the rise over the run, as we're used to. But what that really means is the second y coordinate minus the first y coordinate divided by the second x coordinate minus the first x coordinate. Okay, so now let's consider, given that, consider the slope of the line, the slope m of the line through the points, Let's do P at xy, and let's do Q at x1, comma y1. Then the slope m, which is the change in y over the change in x. So we know it's going to be the second y coordinate in our case. Well, let's make it the purple guy. So y and x will make the second, y1 and x1 will make the first. Not that it matters. Okay, I can cross multiply here by x minus x1. So I'm just multiplying the denominator across, and what I get then is slope m times the quantity x minus x1 when I cross multiply, and that will be equal to y minus y1. Now if I flip this around to being, let me just copy and paste, y minus y1 is equal to the slope m times the quantity x minus x1. This is the point-slope form of a line, right? Oops. Autocorrect, come on. Really? Okay. I'm the only one I know in this world who has so many computer issues. Okay. Okay, so this is the point-slope form of a line. And that point-slope form comes directly from the equation for the slope. Okay, so for example, let's do an example now. Example. How many of these do I want to do? Okay. So use the point-slope form of a line. The point-slope form of a line. To find the slope-intercept form of a line. To find the slope-intercept. Form of a line. In the following. So number one, what do we have? Points P at 1, 3 and Q at 4, -3 lie on the line. Okay, so the first thing we want to do is find the slope m. Maybe I will do that in orange. Okay, so let's call point P the blue guy and point Q the purple guy. So I claim that the slope m, which I know is y2 minus y1, oops, come on, y2 minus y1 over x2 minus x1 so for us, that's going to be, so y2 is -3, from which we're subtracting y1 is 3. x2 is 4, from which we're subtracting x1 is 1. So what do we have here? We have -6 divided by 3. So I claim that the slope is -2. So now step 2 will be point slope form of a line. Point slope form of a line. So we have y minus y given. And let's use point P, not that it matters. Y minus y given is equal to slope m times the quantity x minus x given. And we'll use point P. So I could have used point Q, it does not matter. So plugging in, we will get y minus, what is the y coordinate of point P? 3. is equal to, what's the value of the slope? We found that it was -2 times the quantity x minus the x coordinate of p is 1. So we can distribute. So we get that y minus 3 is equal to -2x plus 2 when I distribute. Okay, so now let's add 3 to both sides, and I get that y is equal to -2x. Let's think about this. 2 plus 3 will be plus 5, right? So there we are. This is the equation of the line using the point-intercept form. And notice when we simplified, when we solve for y, we get the slope-intercept, right? So we know that let me reiterate that. The slope we found to be -2. And what is the y-intercept? I probably should have called that a different color than blue. Let's call this green so it's different. I'm going to call this green because I don't want it to be confused with the point P. So 0, 5 is equal to the y-intercept. Okay, so let's do another one. Oh, by the way, before I move on, is the slope positive, negative, 0, or undefined here? Well, the slope is negative. So do you agree that this is decreasing? It's going downhill because it's a negative slope. It's good to note that, so when we go ahead and plot these things later on, it'll make sense. Okay, so subscript number 2, let's say points P at -1, -5, and Q at 3, -1 are on the graph. So once again, step 1 is to find the slope. So step 1, slope m, which we know is going to be y2 minus y1. Once again, let's call P the blue and Q the purple. Not that it matters. You could swap the order, you'll still get the same answer. Okay, so we have y2 minus y1 over x2 minus x1. And what that gives us then will be see, the second coordinate has a -1 for y and a 3 for an x, whereas the first coordinate has a -5 for a y and a -1 for an x. So notice my negatives, 2 negatives make a positive. So what do I have here? I have 5 minus 1, or 4, in the numerator over 4. So my slope is 1. Okay. So now step 2 is to use the slope-intercept form to get the, use point-slope form. Point-slope form to find slope-intercept form. So we'll have y minus y given is equal to, and I'm going to use the other point this time. Not that it matters. Let's call this y sub 2, not that it matters, will be m times the quantity x minus x sub 2, or x sub whatever we want it to be, because we can choose our points. Okay, so this will be y minus, now the y coordinate for q is -1, so this will be y plus 1 is equal to, we found that the slope was just 1. It's a terrible 1 times the quantity x minus, and the x-coordinate of q is 3. Okay, so we can distribute the 1, but that's pretty simple. So I'm just going to go ahead and subtract 1 from both sides. So we get that y is equal to x. So I have a negative 3, and I'm subtracting 1, so minus 4. I'm going to do this in green because I want us to note the y-intercept. So we've gone from point slope to slope-intercept form. Oh, come on. Verdammte Sache. There we go. Okay. Okay, so we agree that the slope was 1. We found that earlier. And 0, comma, negative 4 is the y-intercept. And let's note that this is greater than 0, so increasing. But do you know what I didn't find? Let's go ahead, and while we're at it, since we've got nothing better to do, right? And we've got time. This is a very short section, so I'm trying to increase the material to the time allotted. Let's do, maybe this strange color. Okay. The x-intercept was at negative b over m, right? So that's going to be negative, b was 5 here, over m is negative 2, comma 0. So that's 5/2, comma 0. And I think I'm going to move that to the left a bit. Five halves, comma 0 for our x-intercept. And for this, maybe I'll just put DEC so I'll have myself more room. Because remember, what was x, the x-intercept? Where did I put it? Oh, I forget where I put it. Yeah, here we are. Negative b over m for the x-coordinate. Okay, let's do the same thing here. So the x-intercept will be negative b, so that's going to be a negative of a negative 4. So that's going to be positive 4 divided by m, which in our case is just 1, comma 0. So the x-intercept is going to be 4, comma 0. Okay, interesting. So now let's do a bit different way of doing this. So for example, new example, let's find the slope-intercept form of the following. So find the slope-intercept form given the following. Slope-intercept form given the following. So number 1, you're given that f of negative 3 is equal to 1, and f of 2 is equal to 6. So let's translate what this means. This means that point P has an x-coordinate of negative 3 and an f of x or y-coordinate of 1. This over here, point Q, has an x-coordinate of 2 and an output y-coordinate of 6. So I can find my slope. My slope will be y2 minus y1 over x2 minus x1. Okay, so what do we have? So y2 minus y1 over x2 minus x1. So for us, y2 is 6, and y1 is negative 3, so, no it's not. y1 is 1, and x1 is negative 3. So what we get then is 6 minus 1 in the numerator, and 2 plus 3 in the denominator. So the slope here is 1. So now shifting to our y-intercept, or point slope form rather, y minus y given, let's go back to the blue point, is equal to slope m times the quantity x minus x given, or x1 in this case. So we have y minus, the y coordinate there was 1, is equal to slope, which we found just to be 1, times the quantity x minus a negative 3. So this is going to be plus 3. Okay, so distributing of 1 doesn't change anything. So all I need to do is add 1. So this will be x plus 3 plus 1 is 4. So I know that my slope, m, is 1. I know that my 0, 4 is my y-intercept. And I know that my x-intercept is going to be at negative b, so negative 4 over m. And m was just 1 in this case, comma 0. So this is just negative 4 comma 0. Okay. We've got that one. So by the way, if my m is positive, this is increasing slope, right? In fact, should we plot it? We could plot it if we want. So if I were to plot this, where shall I plot it? Let me put this down here. So my y-intercept is negative 4 and my slope is 1. So that's fairly simple. No, my y-intercept is 4, sorry. Gotta read, that's my x-intercept is negative 4. So 1, 2, 3, 4. 1, 2, 3. I think I'll make then my negative y-axis a bit smaller. 1, 2, 3. 1, 2, 3, 4. And I'll make my positive x-axis a bit smaller as well. Okay, so using the point slope form of a line, my y-intercept is 4. My x-intercept is negative 4. And the slope of the line is 1. Now, is that slope 1 between those 2 points? It is, because I rise 4 and I run 4, so my slope is 1. Okay, interesting. So maybe we'll plot all of these. Find the slope intercept form given the following and plot, comma, and plot, because that'll let us see what's going on there. Okay, so number 2. Let's say we have that f of 7 is 5, and f of 3 is negative 7. So once again, we have 2 points here, P. Point P is going to be x-coordinate 7, y-coordinate 5. And point Q, we'll have input x, 3, output y, negative 7. So the first thing we do is find our slope. So our slope will be the change in y over the change in x, namely y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. So that's going to give us a negative 7 minus 5 all over 3 minus 7. So what's that? Negative 12 over negative 4, or 3. Okay, so use the point-to-slope form of the line. So we have y minus, let's use the purple guy this time, y given is equal to slope m times the quantity x, oh, come on, why can I not draw a parentheses, x minus x given okay, so we have y minus, in this case it's going to be a negative 7, so this will be plus 7 is equal to, we found the slope was 3 times the quantity x minus 3. So now let's distribute that 3 into this parenthetical. So we get that y plus 7 is going to be equal to 3x minus 9. So now I'm going to subtract 7 from both sides. So we get y is equals to 3x minus 16. Okay, so this is the equation in slope-intercept form. Oops. Okay, so we know that the slope was 3, and that's positive, so that's increasing, right? We know that the y-intercept, that 0, comma, negative 16, is the y-intercept. But what about the x-intercept? Well, the x-intercept will be at negative b, so negative of a negative 16 divided by m, which is 3. Comma 0, which is 16 thirds, comma 0 is the x-intercept. Okay, so these are ugly numbers, but let's go ahead and whenever you have something this ugly, just guesstimate it. Don't worry about getting the exact numbers. X and y. So what I'll do, I'll just put a random point down here, call it negative 16. Now, 3 goes into 16 5 times and 1/3. So what we're going to do is we're going to plot the point at negative 16. And then we're going to go 1, 2, 3, 4, 5, and 1/3. Now we'll just connect the dots. And do you agree that this is an increasing slope? Yes, it is. Okay, so let's do a third one. So number 3, we're given that f of 0, is negative 2, and f of 3 is 0. So our slope, well, first I have to give you the points. So point P is going to be at input x is 0, output y is negative 2. Point Q is going to be at input 3 and output y is 0. So now the slope which is the rise over the run, will be y2 minus y1 over x2 minus x1. So for us, what's that going to be? Oh, come on. Why does this autocorrect always fix? Fix. Okay. Well, what's nice about these numbers, there's lots of zeros. So y2 is 0. y1 is negative 2. And then we have 3 minus 0 on the bottom. So it turns out that the slope is just 2 over 3. Slope-intercept form gives us y minus y given. Let's use the blue one again. Is equal to slope m times the quantity x minus x given. Okay, so we have y minus then a negative 2, so plus 2, is equal to 2/3 times the quantity x minus what amounts to 0, thank goodness. So subtracting 2, we have that y is equals to 2/3 x, then minus 2. So I know my y-intercept, so my slope. Let's go ahead and put a box around this. Nope, okay. Wow. It's supposed to auto do this. Okay. So we know our slope is 2/3, which is greater than 0, so that's increasing. I'm going to see if I can put this on here. Maybe not. Well, my y-intercept is 0, negative 2. It's the y-intercept. And negative b over m, 0, simplifies to 3, 0 as my x-intercept, because I invert and multiply. Okay, I think I can plot it all on here. So, y-intercept of negative 2, x-intercept of 3. That's fairly simple. Now, let's see, if my y-intercept is negative 2, my x-intercept is positive 3, and I connect the dots, will it have the correct slope? Namely, will the slope be rise 2, run 3? Yes, it is. Okay, so let's do one more example before we stop this section. So example. So given the following graphs, find the equation. Okay, so subscript number 1. Let's do x and y coordinate axes. So let's do 1, 2, 3, 4. 2, 3, 1, 2, 1, 2, 3. Okay, x and y. Let's say my graph looks something like so. Up 3, over 2. So this is my f of x. So I claim that 0, 3 is the y-intercept. And I claim that that my slope will be rise a -3 and run a +2. So the slope is -3/2. So therefore, these two together give me that y is equal to m -3/2 x. So mx plus b, well, what is b? It's 3. So actually, maybe I'll give you guys the formula for that just in case. So we want y is equal to mx plus b. Y is equals to mx plus b. Okay, so let's do number 2. X and y coordinate axes. Let's go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So let's say now that my intercepts are 2, 3, 4, something like so. That's a terrible plot. Okay, so here, if this is my function f of x, my y-intercept, so 0, 6 is the y-intercept. Now my slope is going to be well, let's go from this point down here. Looks like I'm going to rise a +6 and then run a +4. So my slope will reduce to 3 over 2. And using y equals mx plus b, we can just plug in what we know. So we get that y is equal to slope 3/2 x plus 6. So there we are, slope-intercept form. Okay, let's do one more, and then we'll be done. And maybe 2 more for good measure. 1, 2, 3. Let's say we have, what do I want to do? Okay, let's make this a small graph. X and y. Let's do 1, 2, 1, 2, 1, 2, 1, 2. Okay, let's say we have something that looks like so. Okay, so the first thing I note is that my y-intercept is at 0, -2. That's my y-intercept. Okay, so my slope is going to be rise over my run. So if I rise, it'll be a positive 2. And if I run to this next point, it's going to be 1. So my slope is just 2. So now using slope-intercept form, y is equals to mx plus b. We get that y is equals to 2x plus, well, b is negative 2, so this will be 2x minus 2. There we are. That is the point slope-intercept form. And one more for good measure. Should I move that down a bit? It feels a bit cramped. Let's move this down at least 1. There we go, a bit better. Okay, so number 4. What if we had something that looks like so? If this is my f of x, then I claim that 0, 3 is the y-intercept, and I claim that my slope is rise nothing and run whatever I like. Let's say we run 2. Doesn't matter how far you run, because as long as there's 0 in the numerator, the slope is 0. So now, if we have y is equal to mx plus b, we get that y is equal to 0 times x plus 3, which simplifies to y is equal to 3. And we know horizontal lines are of the form y equals 3, but we'll get to that in the next section. Okay, this is a horizontal line. It's well defined, right? It's the vertical lines that aren't well defined. So I will see you in the next section.